I'm going. Morning, guys. We are on page 185, looking at 3.1, talk to talk. Oh, I'm famous, huh? Here we go. Katie. Mr. Bernal, could you read to us about Katie?
Katie received a $75 gift card for her birthday. She decided to buy music and movies for her electronic notebook with the gift card. Songs cost $129 each, and movies cost $14.99 each. Write an equation to represent this problem situation. Use S to represent the number of songs and M to represent the number of movies.
Okay, so let's go back to our given information and sort out what we know. We have a gift card with $75 on it. We have two types of things that she's going to buy. What is she going to buy? Songs. Songs cost $129 each. What else is she going to buy? Movies cost, and they put it over to the other side, $14.99 each. So it's kind of like the adult price, ticket price. She's going to buy a little bit of both. And what's the grand total? What's the max amount she can? 75. So if we're going to write it like an equation, they gave us some variables. They told us to use an S for songs and use an M for movies. Okay, if I'm working with this the same as I did adult tickets, student tickets, say I start with an S, what do I need to put with that S? The cost of a song. What is the cost of a song? $1.29 goes in front of the S. It's a little more complicated than having a 5S, but it's the same thing, and it's real life, okay? Real life often has some sort of pennies there, okay? Songs plus, what's the other, Andy, I'm not sensing you're focusing up this way. Songs plus what? Movies, and I hear somebody already knowing what, 14.99 for every movie equals, what's the grand total again? 75. The last time we did something like this, we had an amount of money we were going up to. This one we kind of have, or that they wanted to make for a profit. This one is an amount of money. That's all she has on her gift card. She can't go over it. Okay? All right, so there's our expression. Again, it's in standard form, it's called, because both of the variables are on the same side of the equals. And the number, or the constant, the amount that doesn't have a variable is on the other side of the equal sign. It's organized differently than y equals ms plus b. Okay, did you see any of that? Okay, this is an there we go. It's Monday, yes? Okay. This again is standard form because the two variables are on the same side of the equal sign. The other form that you'll hear in linear equations, slope-intercept, isolates one of the variables and moves everything else over. But starting here, complete the table, show that each expression represents in this problem situation. S, what is that? Songs. It was students before, but it's songs this time. M, what is that? Got a little bit of a shimmery. There we go. 129. What's that? What about the song?
How much one song?
How much one song costs? $14.99.
Movie.
How much one movie costs? 1.29 times S. Okay, what does that represent? What? Cost per song, but that's going to be amount of money that she's spending on songs. It'll be a different amount if she's buying one song. What is up today, huh?
Your Minecraft app is on.
My Minecraft?
Hey, I forgot to close it.
Okay. Here we go. It's going to go again. Oh, well. We won't look at it. Money she spends on songs. What's this? Money she spends on movies. So if she buys 2 movies, she's going to spend 2 times $14.99, right? She would times those 2 together. Money she spends on movies. What happens when you add those 2 together?
And the total amount she spends.
Total she spends.
$15.20.
You don't know that yet because you don't know how many of each. She could have bought 10 songs and 1 movie. She could have bought 1 song and a couple of movies. Okay, so we don't exactly know the amount. We know it can't be over 75. So what's this 75?
Max.
Maximum amount. She may go shopping right after birthday and not spend it all, yes? Maybe she goes in the first time and buys a couple of each and then holds on to her gift card, but some of the money has been subtracted. Okay, here we go. Now we're getting some specifics. Number 3. Brody, could you read 3 for us?
If Katie buys 20 songs, what is the greatest number of movies she can buy?
Here we go. We have an amount of songs, finally. Everything else was kind of organizing and hypothetical, but now she has 20 songs. How much does 20 songs cost? 1.29 times 20. How much is that? Excuse me? 25.8. Okay, so maybe we need to look at that in terms of our equation. What I just did there in multiplying those 2, that's the first part of the equation. Here's our equation. S plus 14.99 movies equals 75. Now what I just figured out is this part, so 1.29 times 20 is all that fitting in the screen? Awesome. Or replacing this, 25.8 plus, what should I do next? Wait, I'm missing something. M. I want to find out M. I want to know how many movies can she get. How can I get M by itself? Subtract, right? This is the amount of money that she spent on songs. We got to see what's left. What are we going to subtract that from? 75. In equation, I'm going to subtract it from both sides. Goodbye to this. What's left on this side of the equation is 14.99M. What's left on this side is what you get after you subtract the 25.8 from 75. 75 minus 25.8, 49.2. Now that doesn't tell me a number of movies yet. That tells me how much money's left to spend on movies. How do I find out how many movies I can get? Yes.
You divide by 14.
Divide. Movies are $14.99 each. However many times this goes in there, and it may not go evenly, but however many times it goes in there will tell us M. Okay, so divided by 14.99, I'm getting M equals 3.28. Now that's mathematically correct, but I got to think of my scenario. If I'm trying to buy movies, are they going to let me buy 3 movies?
Yeah.
Are they going to let me buy 4 movies? Are they going to let me buy 0.28 of a movie? That's about a third of a movie. No. So mathematically, we would stop right here with our answer, but for our situation, we're going to say 3 movies. She has enough money left over after buying 20 songs to get 3 whole movies. Then there'll be a little bit of money left. She didn't spend it all. She could have bought a fraction of a movie, but that's not the way movies are sold. Okay, they're sold in whole numbered movies. All right? You with me? Flip the page. Kenya, could you read number 4, please?
If Katie buys no movies, what is the greatest number of songs she can buy? What does this number represent?
Okay, no movies. Katie buys no movies. What kind of number value would no be?
0.
0. Okay, so if I go back to my equation, 1.29s plus 14.99 movies equals 75. They just told me movies is 0. They just told me this piece is 0. No movies are getting by. Okay, so what I know then is 1.29s is the amount of money, or I got the whole 75 just for songs. How could I figure out how many songs she can buy? Divide. S equals. Again, we may not come up with a whole number answer. Go ahead, divide, and figure out how many whole songs can she buy.
58.2222.
Okay, but again,
You can only buy 58 volt. Oh.
58 songs. So mathematically, we see she could buy a little over if they sold parts of songs. But since they probably only sell whole songs, she's going to buy 58 and have some change or a little bit of money left on her gift card. Okay? They asked the second part of this. What does this number represent? Okay, for that, we might need to look back at what we were working on Friday. Flipping back, flipping back, flipping back. Here we go. Page 180. This is where we left off on Friday. We were looking at what are called intercepts. Y-intercepts, and x-intercepts. And intercepts, you can see I have a pink and a yellow dot. What does the word intercept mean? Where two things crossed, but in the case of working with a Cartesian coordinate plane or an x and y axis, y-intercept, what does that mean? Where this line crosses the y, and x-intercept is where that line crosses the x. And now, here's one of the tricky things. We looked at, what does this tell us? Y-intercept, we said, was 600 students, because the y-axis in this arrangement represented students. Here's the other thing to notice. It's 600 students, but how many adults is it? If I'm right here, hello? If I'm right here, 600 students, and adults is the back and forth, do I have one adult? Two adults? Do I have -1 adult? -2? If you're right here on this line, how many adults do you have?
0.
0. The intercept tells you amount of students, but another key feature is because you're right here in the middle, you're at 0 for this accent. So 600 students, 0 adults. Down here, right here in pink, we were looking at adults because that's where it crosses the x-axis. That's the x-intercept. We said that's 300 adults because that's a measure of adults along here. How many students? Again, students is up or down, and again it's 0. We're not up, we're not down, we're right. If you look over at the up and down axis, we're right at 0, so 0 students. One thing to know about an intercept, Andy, is because it's where it crosses the axis, it's a value for one of your variables, but a 0 for the other. Okay, so let's go back to songs. If Katie buys no movies, what is the greatest number of songs she can buy? 58 songs. Okay, we don't really have a x and y axis, but this is going to be an intercept. All right. If I made a little x and y, I would make one of these movies. It doesn't matter which one, and one of these songs. What I know, if this is 58 for songs, let's say I go by tens, 10, 20, 30, 40, 50, 60. 58's going to be right about there. Songs. 58 songs, 0 movies. Again, 58 songs, but I'm not up and I'm not down for movies. Is that too low? Okay. Number 5 is going to ask us for the opposite thing, I bet you. Number 5. Ernesto, could you read 5 for us? Okay. So no songs. So again, no equals 0. Again, if I look at my original... Now I'm too... There we go. If I look at my original equation, 1.29s plus 14.99m. No songs this time means 0 right here. 14.99m is the only part of the equation left. If I want to solve for m, what's the math I need to do? Divide. That'll get M by itself. Who's done the divide?
This one.
5 exactly? Oh, nice. 5. Okay, so movies, this axis I'm going to number differently. 1, 2, 3, 4, 5. 5. This was by tens, that's 60. That's okay. If they're different things, the axes can be labeled differently. But again, that's 5 when songs is 0. Excuse me a minute.